For this video we use the following schema. In the package simple extra, we have a class called item. This class has the field's name and description. To create the class files and the database table from the schema, we use the extra builder. Go to Extras, Extra Builder, Package Builder. Click the button Import Schema, and paste the schema. Then click Save. Open the package and under Build Actions, choose option 1. Verify that there are no errors. In phpMyAdmin, we check if the custom database table exists. Then we add some test data. The code in this tutorial is based on the article Developing RESTful APIs from the MODX documentation. Let's copy the sample code for the index.php file. In the MODX base directory, on the same level as the core and assets folders, create a new folder REST. Inside the REST folder, create a new file index.php and paste the code. Delete the lines with the custom package myPackage. Our own custom package is already loaded by the bootstrap PHP file in the folder core, components, simple extra. Copy the content for the .htaccess file from the article. Create a new file .htaccess in the REST folder, and paste the code. Add a line for the rewrite base. Make sure the value corresponds to the name of the folder. In our case it's REST. Then adjust the paths in the two rewrite rule lines. From the article, copy the sample code for the API endpoint. In the REST folder, create a new folder controllers. Inside this new folder, create a new file items.php, and paste the code. We add the namespace to the controller class we extend, to make it work in MODX 3. Then we change the class key to our own class simple extra /model/item. We change the default sort field to ID, and add a line for the class alias. In a new browser tab we test if the API works. When we request the URL /rest/items, the first 20 items of our sample data get returned. Let's take a closer look at the files we created. In the .htaccess file, if a request to the REST folder is not for an existing directory, and not for an existing file with size greater than 0, the request is rewritten to run the file index.php, and the original file path becomes the _rest request parameter. For example, a request to /rest/items gets rewritten to /rest/index.php, _rest equals items. If a request is for an existing directory, then it also gets rewritten to run index.php, but the _rest request parameter is not set. This basically results in a response with an error message. I think this code could be simplified to just run index.php for every request to the REST folder. Currently, the code for the file index.php from the documentation is still the same for MODX 3 as for MODX 2. The code runs but could be optimized for MODX 3. From the article Loading MODX externally of the MODX documentation, copy the code and replace the existing one. Also, I believe getService is deprecated now in MODX 3. It could be replaced by directly instantiating the ModRESTService class. In the call to the constructor, we define where the files for our API endpoints are located. In our case, in a controller's subfolder. We also define that our endpoint controller classes have a class name prefix of myController. What is possible with our endpoint out of the box? We have seen that we can request multiple items with /rest/items. If we add an ID, for example /items/1, we can request a single item. The ID could also be added as an ID request parameter. To sort the items differently, you can add a sort request parameter. Now the items are sorted by the description field. With the dir request parameter, you can change the sort direction. By default, the amount of returned items is limited to 20. You can change that by adding a limit request parameter. By adding a start request parameter, you can change the offset to load a different page. If you don't want any pagination, go to your controller class and add a property default limit with a value of 0. Now a request to /rest/items returns all the existing items. There is also a search request parameter. But you have to adjust the controller class to make it work. Add a property search fields to your class, with an array of all the fields that should be searched. Now the search parameter works. To test the other request methods, we can use the application Postman. The method post is for creating new items. If we don't supply any data, a new item is still created. To avoid this, we can change our controller class. We add the property post required fields, with an array of all the field names that are required. Now if we try to add a new item without data, the request is not successful. There are different ways to add the data. We can, for example, add request parameters to the URL. Another way is to add the data to the body. It's also possible to supply the data as JSON. The put method is to change an existing item. We have to supply the ID of the item we'd like to change. Otherwise the request is not successful. We can add the ID to the URL. The ID can also be added to the body instead. The delete method is for deleting items. We also have to supply the ID of the item we want to delete. If no item with this ID exists, the request is not successful. It's also possible to add the ID to the body instead of the URL. As we have seen, even without any authentication, it is possible to change the data. This is dangerous and we have to protect our endpoint. You are free to implement authentication any way you like. For example, by checking for a specific token in the request. But in this tutorial we use the normal MODX cookie. To implement this, we install the extra login, so that the user can log into MODX on the front end. We add a new user group called API user. Then we add a new user and make them a member of this user group. In the resource items, we add some test code that uses Alpine.js. In the code, we first call the snippet login so that the user can log in. We output whether the user is logged in, and the username. We load the Alpine.js library that is used in our JavaScript code. The page outputs a potential error message, the total amount of items, and a list of all the items. Every item in the list has a delete button to delete the item. In the script section, we define the URL of our REST API. There are variables for the items and the error message. In the function load items we use fetch, to make an AJAX request to the API and load the items. If the request is successful, we store the data in our variables, so that it gets displayed. The function delete item is used to delete one item. With fetch we make a request, using the delete request method. If the request is successful, we reload all the data. Let's view the page in a new private browser window and see how it works. Without being logged in, we can load the data and delete items. Where in the code can we protect the endpoint? In our file index.php, we call the function check permissions on the REST service class. But when we check the code under core, src, revolution, REST, mod REST service, we can see that this function always returns true. We'd have to create our own service class that extends mod REST service, to override this function. Another possibility is to override the function verify authentication in our controller class. Let's do that. With this request method, we can access the request method that is used in the request. We return true if the method is get, so that everybody can read the data. With this MODX user, we can access the information about the current user. We can, for example, check if the user is authenticated in the web context, or if the user is a member of a certain user group. Let's test that in the browser. Now, if we are not logged in and try to delete an item, the API returns an error message. But just loading the data still works. And when we are logged in, deleting an item works as well. We can extend our JavaScript code to enable the creation of new items. We create a new button to add items and a form. The form executes the save item function when we save it. It executes the cancel item function when we click the cancel button. The form has an input field for the name and a text area for the description. We add new variables to store whether the form is visible and the form data. Then we add the add item function, that is called by the add new item button. The function resets all the form fields and sets the focus on the name field. Then it shows the form. The cancel item function deletes the entered form data, and hides the form. We add the save item function. This function makes a request to the API with fetch. The request method is either post or put, depending on the value of the item ID. This way, the same function can be used as well to update existing items. We add the data as JSON to the body and add a content type header, to indicate that we are sending JSON data. If the request is successful, we reload all the data and hide the form. Now we can add new items in the front end, but only if we are logged in. To enable the user to update existing items, we add an edit button to the items list, that calls the edit item function. This function is similar to the add item function, but we first search for the correct item in our items array, and then fill the form with the found data. Now on our web page, we can update an existing item, if we are logged in.